determine whether this type 1 improper integral converges or diverges. If it converges, determine the value of the integral. So we're going from 5 to positive infinity, and 2 to the x is our integrand. That's the function. Okay, so what do we do? Now, before we actually get started, you might have a think about our function. 2 to the x is exponential. And if we're integrating from 5 to infinity, we might expect just by the picture of a graph for this thing to diverge. But let's actually write it up nice and neat and take a look at what's going on. So, for a type 1, or really for any improper integral, we should rewrite as a limit in terms of definite integrals that we can work with. So we'll go from 5 to b, 2 to x. All right, so now what do we do? Well, it's a definite integral from 5 to b. We know how to work with these. Okay, what's an antiderivative for 2 to the x? 2 to the x over ln 2. So we'll evaluate that from 5 to b and take the difference. And then once that's done, we'll get an expression involving b, and we can take the limit. So we'll get 2 to the b over ln 2 minus 2 to the 5 over ln 2, which I suppose if you want to, you could do a number of things. You could simplify the 2 to the 5 as 32. You could pull it all together as over ln 2, or you could even take out the 1 over ln 2. Take that out. And lots of things we can do, but ultimately the question is, what's this limit going to be? Okay, and so we ask ourselves, as b gets bigger, what does 2 to the b do? Okay. As I raise 2 to larger and larger powers, think 2 squared is 4, then 2 cubed is 8, then to the 4 is 16. As b gets larger, this gets larger. This heads towards infinity. Okay. So our integral diverges. It does not settle down to one particular value. So there we go. We're all done.